Hi everyone, today we are going to learn about method number 2 for simplifying complex fractions. Method number 2 is the preferred method for pre-calc, and it will also help us to solve rational equations, which is our next lesson that we're going to be learning. But before we get started, let's talk about what method number 2 looks like. Now, method number 2 is a way to simplify complex fractions. And what you do for method number 2 is you multiply the numerator and the denominator. So that is the big numerator and the big denominator. I'm going to call them big. The big numerator and the big denominator by the least common denominator of every fraction in the numerator and the denominator. We call every fraction the little fractions. So we are going to come up with the least common denominator of all of the little denominators. And then from there, we're going to simplify. So, like I said, the method number 2 is the preferred choice for pre-calc, as well as algebra 3 with trigs. And method number 2 will help you when it comes to solving equations. So it's very important that you feel comfortable with method number 2. So we're going to look at our warm-up, and our answer, if we do it correctly, should end up being 39/5. And that's because these two problems are exactly the same. So remember that in method number 1, our goal was to turn the numerator and the denominator into a single fraction. And then from there, we used our rules for dividing fractions in order for us to solve. This time around, in method number 2, our goal is to eliminate the fractions in the numerator as well as the denominator. So that is what our goal is. Our goal is to completely eliminate the fractions in the numerator and the fractions in the denominator by multiplying the big numerator and the big denominator by the common denominator of all of the denominators, which I know sounds very confusing. So what is a big denominator and a big numerator? Well, this whole quantity, 3/2 minus 1/5, this is considered your big numerator. And 5/6 minus 2/3, that's considered your big denominator. So we have a big numerator and the big denominator. Now, what are your little denominators? Well, we're going to start off by listing our little denominators. Our little denominators are 2, 5, 6, and 3. And we need to come up with a common denominator between 2, 5, 6, and 3. So what we need to do is we can either prime factor, or we can make sure that, that each factor is represented once. Highest degree wins. So a 2 is just a 2. A 5 is just a 5. It's 2 times 1, 5 times 1. A 6, that is a 2 times a 3. And a 3 is just a 3. So making sure that we multiply each just one time, each one is represented just once, our least common denominator of all of the little denominators is going to be 2 times 5 times 3. So we need 1 2 to be represented, 1 5 to be represented, and 1 3 to be represented. 2 times 5 is 10, and 10 times 3 is 30. So what I'm going to do is I'm going to multiply the big numerator and the big denominator by 30/30. So what does that mean? Well, I'm really multiplying the top and the bottom by 30/1 over 30/1. So I'm going to distribute 30 to every single fraction. So you have to be kind of careful with this. So what happens here is we have 30 times 3 divided by 2. So 30 times 3, that is 90. And 90 divided by 2 times 1, which is 2, 90 divided by 2 is 45. 30 times 1 is 30. 30 divided by 5 is 6. And the denominator, 30 times 5 is 150. 150 divided by 6 is 25. Minus 30 times 2 is 60. 60 divided by 3 is 20. So now what's nice is that I just eliminated all fractions in the numerator and the denominator, and now I'm going to simplify. 45 minus 6 is 39, and 25 minus 20 is 5, and there's my answer, 39 over 5. It is less steps and less work than method number 1. What we did, once again, is we took all of our little denominators and came up with the least common denominator of all of the littles. Then we multiplied the numerator and the denominator, all fractions in the numerator and the denominator, by 30. It was a 30 over 1. From there, the fractions eliminated. And then we just simplified the numerator and the denominator individually to get our answer. So let's go ahead and look at method number 2, letter A. Notice that letter A for method number 1 and method number 2 are the exact same. So if we do this correctly, we should end up with 5x over 3x plus 8. So the first thing we want to do is we want to look at all of our little denominators. So our little denominators are an x plus 4, and we also have an x plus 4 right here, and an x. So our least common denominator of all of the little denominators, our LCD, is going to be x times an x plus 4. So that's what I'm going to multiply the numerator and the denominator, the big numerator and the big denominator by. So I'm going to put both the big numerator and the big denominator in brackets, and I'm going to multiply it by x times x plus 4 over 1 divided by x times x plus 4 over 1. So now I'm going to multiply straight across. So I end up with 5x times 5x times x plus 4 all over x plus 4 all over, I have an x times an x plus 4 over an x plus 4 plus 2x times x plus 4 all over x. So remember that your goal for method 2 is to eliminate all little fractions. That's your goal, to eliminate all little fractions. So watch what happens. Notice I'm keeping everything in factored form. Everything stays in factored form. I'm not going to distribute until my little fractions are gone. So now I'm going to eliminate the x plus 4s, and I am left with, in my numerator, 5x. Down here, I'm going to eliminate my x plus 4s. So in my denominator, I start with an x plus. Over here, the x's eliminate, leaving me with 2 times an x plus 4. My goal of eliminating all little fractions is done. That's awesome. So now I'm just going to simplify this fraction like I normally would. So now I have a 5x over x plus, and I'm going to distribute that 2 to each term to make it 2x plus 8. My answer is 5x over 3x plus 8. And that is it. That is all you do. So what we did is we multiplied the numerator, the big numerator, and the big denominator by the least common denominator of all of the little denominators of the fraction. Then from there, we have to remember that our goal is to eliminate all little fractions. This is different than method 1. Method 1, we wanted to have fractions. We wanted a single fraction over a single fraction. In method 2, we don't want any more fractions. We just want to have it be a normal problem. So that's the actual difference. Our goal is to eliminate the little fractions. We have a few more examples. Here we go. Letter B. The first thing we want to do is we want to look at our identify what all of our little denominators are and come up with the least common denominators of all the littles. So our little denominators, we have an x minus 5, we have an x, and it looks like we have an x and an x minus 5. So our least common denominator of all of the denominators, let me rewrite this so that we actually have space to do our problem. Otherwise, we won't be able to do our problem. I'm just going to rewrite it up here. So we have our little denominators. We have an x, we have an x minus 5, and so our LCD is going to be x times an x minus 5. So that's exactly what I'm going to multiply both the numerator and the denominator by. I'm going to multiply the numerator by x times x minus 5 over 1 divided by x times x minus 5 over 1. So I'm going to multiply or distribute this to each little fraction, to each term. So now when I multiply it, I'm going to have 6x times x minus 5 all over x minus 5 plus I have 1 times x, which is x times x minus 5 all over x. If you can see what you're going to be eliminating from the beginning, then you don't have to show this step. But I feel like while we're learning this method, it might be helpful just to show all steps until you feel more comfortable. Divided by, we have 3x times x minus 5 divided by x minus 2 times x minus 5 divided by x minus 5. So now from here, remember that with method 2, our goal is to eliminate the little fractions. At this step, do not do any sort of distributing. We are not there yet. Our goal is to eliminate the little fractions. So I'm going to eliminate the x minus 5s. And so I'm left with 6x plus the x's cancel out. So I'm left with an x minus 5. That's my new numerator. My denominator, the x's cancel out. So I'm left with 3 times x minus 5 minus the x minus 5's cancel out, leaving me with 2x. What's awesome is that in method 2, I want my little fractions to go away. And now my little fractions are gone. So I'm going to clean this problem up a little bit and make it an easier problem to work with. So 6x plus x is 7x. So I have 7x minus 5 in the numerator. And I'm going to distribute the 3 to each term to make that 3x minus 15 minus 2x. So my final answer, we have 7x minus 5 divided by x minus 15. 3x minus 2x is 1x. And there's my answer. All right, let's go ahead and look at letter C. For letter C, I'm going to look at all of my little denominators, my little d's. And I have a 10, which I can rewrite that as 2 times 5. I have a 5, I have a 2, and I have a 4, which I know is 2 squared. So remember that whenever you're coming up with your least common denominator, that means that we want to have every single degree, or every single factor represented, highest degree wins. So we're going to need a 2, certainly, because we have 2 2's. So we're going to have a 2, but which 2 wins? The one that has the 2 squared. So 2 squared is going to be part of my LCD. I also have a 5 involved, so I'm going to multiply also by 5. So I only had 2's and 5's, and my least common denominator is going to be 4 times 5, which is 20. So I'm going to multiply both the numerator and the denominator by 20. The big numerator and the big denominator by 20 over 1. So I'm going to multiply by 20 over 1 divided by 20 over 1, and I'm going to distribute. Now remember that your goal for method 2 is to eliminate all little fractions. So when I distribute, 20 times x is going to be 20x over 10. Minus 20 times x, that's going to be 20x over 5. divided by 20 times x is going to be 20x over 2 minus 20 times 3, which is 60 over 4. So I still have my littles, but now notice that I can start eliminating. So if you can already see what it's going to eliminate to before and not have to show this stuff, that's awesome. If you can go straight to what I'm about to write, that's a good thing. That's the goal. But if you're not there yet, don't worry about it. So we have 20 over 10, which is going to be 2. So we have 2x minus 20 over 5, that is 4x, all over 20 over 2, that is 10x, minus 60 over 4, which is 15. So now I'm going to clean it up a little bit. And 2x minus 4x, that's negative 2x, all over 10 minus 15, which I know 10 and 15 both have in common a 5. So I'm going to factor out a 5, and my leftovers is going to be 2x minus 3. You may not eliminate the 2 x's. You cannot do that. And that's because the 2x minus 3 is inside of a parenthesis, and so therefore you cannot eliminate it. Therefore, this is simply our answer. All right, we have one more problem and then we are finished. But let me make sure that I write down on your notes that for letter B, we did method 2. And for letter C, we did method 2. And what we're about to do for example number 10 is also going to be method 2. So it says a college student drives home for a weekend. The distance between her home and the dormitory is d miles. Her average speed coming home is r sub 1, and her average speed driving back to college is r sub 2. So her average driving trip is given by the complex fraction 2d divided by d over r sub 1 plus d over r sub 2. Simplify the complex fraction. So that's all that we're going to do. We are just going to simplify the complex fraction. So I'm going to rewrite this as 2d over d divided by r sub 1 plus d divided by r sub 2. And so looking at our little denominators, we have an r sub 1 and an r sub 2. Now we have to assume that r sub 1 and r sub 2, these are our littles, our little d's, have nothing in common. We have to assume that. So therefore, our least common denominator, our LCD, is going to be r1 or r sub 1 times r sub 2. So that's going to be what I'm going to multiply both the numerator and the denominator by. So even though there's no little fraction in the numerator, we still need to multiply both the numerator and the denominator by r sub 1 times r sub 2 over 1 divided by r sub 1 times r sub 2 over 1. So when I multiply straight across, I'm going to end up with 2d times r sub 1 times r sub 2 divided by, I'm just going to distribute, and I have d times r sub 1 times r sub 2 divided by r sub 1 plus d times r sub 1 times r sub 2 divided by r sub 2. Now remember that when it comes to method number 2, our goal is to eliminate the little fractions. So I'm going to eliminate the r sub 1s, and I'm going to eliminate the r sub 2s. So that means that I'm going to have 2d times r sub 1 times r sub 2 divided by d times r sub 2 plus d times r sub 1. Now, in the denominator, both of these two terms have in common a d, so I'm going to factor that out. And so I have 2d times r sub 1 times r sub 2 divided by d times r sub 2 plus r sub 1. So I just factored out the d that both of these terms have in common. Now, since the main operation in both the numerator and the denominator is multiplication, I can eliminate the d's. Therefore, my answer is 2r sub 1, r sub 2 divided by r sub 2 plus r sub 1. And if you want to rewrite those in numerical order, that's fine, but you really don't have to. This is considered simplified form. You may not eliminate the r sub 1s. You may not eliminate the r sub 2s because technically the main operation is not multiplication. That is the end of this lesson, as well as talking about method number 2. Please make sure that you feel comfortable with method number 2. And if you have any questions over anything, or if you are struggling, please make sure that you come and see me as soon as possible. Otherwise, I hope you have a wonderful day.